Thank you for joining us today at the TDK Ventures DX Week 2022, the day 4 session on Industry 5.0. If you joined us for the previous sessions, welcome back. We have had an incredible dialogue and exchange of ideas in the past 3 sessions on metaverse, connectivity, and edge computing, discussing the impact of these innovations and how they are likely to transform the way we work and live. To continue this discussion on digital transformation, today we will focus on Industry 5.0. Industry 4 refers to smart manufacturing that merges the physical and the digital world, harnessing interconnectivity, automation, condition based monitoring, machine learning, and real time data to create a holistic, productive, and efficient manufacturing ecosystem. Industry 5.0 is Industry 4, but with a sustainable and society centric goal. Today, we are very excited to discuss all this and hear the thoughts of our panelists. My name is Geeta Dolakia. I am the Portfolio Program Manager at TDK Ventures, the corporate venture capital arm of the Japanese giant TDK Corporation, a world leader in electronics and energy solutions. We at TDK Ventures and TDK have been passionate about the transformation that Industry 5.0 can enable in the innovations pioneered by our numerous startups that we have had the privilege of working with and in our smart factories around the globe. I will be a host and moderator today. I'm very excited to explore all this with our wonderfully diverse and knowledgeable panel of experts that we have gathered here today for today's discussion and with you. Let me introduce the extraordinary women and men participating in today's panel. They come from varying backgrounds in academia, industry, and startups. First, we have Dr. Shaolin Liu. Hi, Shaolin.
Hi.
Shaolin is a fellow and director of Texas Instruments Kilby Labs Sensing and Processing Group. She is responsible for R&D on connected sensors, embedded AI, timing and clocking technologies for industrial internet and automobile applications. She has worked on various embedded processing and communication programs, including smart sensing with edge computing, intelligent industrial sensor network systems, and embedded AI hardware accelerations. She is the co author of more than 60 US issued patents and the recipient of special recognition awards that include the 2016 Asian American Engineer of the Year, the Society for Women Engineers, and the National Women of Color Award for Technical Innovation in the industry category. Second, we have Yasser Al Saeed. Hi, Yasser.
Hi.
Yasser joined Amazon Web Services as the VP of IoT, coming from Qualcomm, where he was the vice president. He held a variety of leadership roles, including managing teams that released Qualcomm's first WLAN chip for mobile phones, led the formation and launch of Qualcomm Innovation Center and the Code Aurora Foundation, which helps solve legal and operational issues around open source software release. Yasser also led the Qualcomm Reference Design Program to expand businesses in China. For the past 4 years, he has managed Qualcomm's IoT ecosystem, including critical parts of the strategy to scale IoT chipsets to key technologies such as artificial intelligence, computer vision, drones, robotics, and 5G. Third is Sony Talonto. Sonita is an accomplished public company's board director and a former Fortune 100 executive. In her 25-year diverse global career, she has led and advised public companies and governments on innovative programs that have delivered positive impacts to business consumers and society. She is a purpose driven thought leader with a passion for advancing women leaders in technology on corporate boardrooms. She was invited to the White House to speak at President Barack Obama's Global Entrepreneurship Summit, to an event honoring AAPI women by the US Secretary of State John Kerry for a roundtable discussing digital transformations. She was recognized by the US Secretary of State Hillary Clinton for her pioneering work in tech women. She is an inductee to the US Asian Hall of Fame, the U.S. Women in Manufacturing Hall of Fame, and is a notable MIT alumni. Fourth, we have Yuki Nakagawa joining us from Japan. Yuki is RT Corporation CEO and president and founder. RT is a company that develops, sells, and trains university students and professional engineers about service robots. She founded RT in 2005. RT is the official ROS supporter of Densowave Kubota, a collaborative robot, and a Jetson education partner. For Google ADK production and sales, RT became the first Japanese company to be introduced at Google I/O in 2011. In 2017, the company received investment from Mirai Sosai Fund as the lead investor to co-develop Foodly, a humanoid collaborative robot for food factories. She is a board member of Roscon JP. In 2015, she was selected as one of the 25 women in the world you should know about in the robotics industry by RoboHub in Silicon Valley. She has published many papers and books and writes for robotics and food magazines. And if you notice in the picture, we have a mascot. There will be a question about that later in the talk. We are now joined by Professor Christian Ramsauer from Austria. Hello, Christian. Christian is a full professor at the Department of Innovation and Industrial Management at Graz University of Technology, Austria. He received his PhD focusing on production management from TU Graz in 1996 and spent 2 years conducting research on process development as a visiting scholar at Harvard Business School. He served as a management consultant for 5 years with McKinsey Germany, focusing on product and process development and strategic issues mainly with automotive and steel companies in Europe, US, and Mexico. As a CEO of a green technology company in Salzburg, he developed it into a fast growing and profitable enterprise. He joined Graz University of Technology in 2011 and is on the board of two startups in Austria. And completing our amazing list of panelists is Anthony Jones. Hello, Anthony. A 30-year technology veteran with expertise in robotics, AI, machine learning, and business transformation, Anthony Jules is co founder and CEO of Robust AI, where he is pioneering a vision of collaborative mobility in robotics. Anthony's exceptional track record as a technology leader is based on his belief that complex problems like robotics require multidimensional and multidisciplinary solutions that are human centered by design. Prior to Robotics AI, Anthony led a number of high performance multidisciplinary teams, building robotics products at Google and X, where he was the head of product and program management for the Everyday Robot project. He joined Google through its acquisition of Redwood Robotics in 2013, where he was the COO and VP of product. Dear panelists, thank you for joining us today from around the world. We are all looking forward to a very lively session with simulating and thought provoking discussions. Let's go through today's agenda. The next 80 minutes of discussions with the panelists will be focused on two key questions. The first one would be, what do you think will be the most impactful innovation that will be realized in the next 5 years? The second one would be, what do you think is the most challenging innovation that will disrupt the market in the next 10 years? The panelists will poll first their responses. Following that, there will be a discussion and there will also be time for some audience question and answers. The answers from our panelists will fuel the initial discussion. We will then shift gears and then have an opportunity for you, the audience, to participate. The way to do this will be with your votes on the answers provided by our panelists, so be sure to have a phone or a browser ready to vote. Let's now get started. Dear panelists, please see the link in the private chat at the right-hand side of your screen and click through to submit your answers to what you think would be the most meaningful Industry 5 innovation to be realized in the next 5 years. We will then use your answers to begin your discussions. We've started getting some answers in already. Augmented reality, robotics and human, smart sensing. Keep them coming. Distributed energy and distributed manufacturing. We have four. Robotics and human integration. We have five. Should we wait for one more? Okay, maybe we can start the discussions with the five questions that we have had. Maybe we should start with robotics and human integration. Anthony, would you like to take it on? This is your
Sure.
idea.
Thanks, Geeta. I'm happy to. Um, I think what is really interesting about where we are right now is that we have access to an incredible amount of data about uh, the status of manufacturing, where things are in the manufacturing process. We have huge amounts of data because of things like industrial IoT. We have huge amounts of data about coming into organizations um, about where things are in the production process. Um, the next step that I think is incredibly important is actually being able to use all of that data in context. And the key that I believe to leverage that is being able to have people's decisions executed by robots or automation as quickly as possible. And to pull that off, we really need a different level of integration between humans and robotics, where humans are in the process. They need to understand what's going on. They need to be able to transparently understand the context that they're in. They need to be able to synthesize that information and make decisions. And then those decisions need to be executed by whatever automation systems exist as part of that process. And some of it may be hard automation, some of it may be more flexible automation, i.e., more cutting edge, some of the more cutting edge robotics that we have access to now. And I think that integration and that tie-in is one of the things that will release a huge amount of value over the next 5 years.
That's a very interesting answer. So, what you said, this collaborative robotics really brings about a merging of various different fields. So, if you want to have a collaborative environment where you have both humans and robots, machines, working together, you have to start from the very design stage. So it includes design, it includes all of the smart sensors that go into the various machines and instruments that one uses. It uses robotics, and then you need to have a decision based science that merges all of this and makes the decisions. So, should we start with the design aspect? So, Christian, would you like to add to this?
Well, if I look at manufacturing companies like here in Europe, in Germany, in Austria, I see lots of robots with fences and robots actually hurting people. I recently heard that in China, where production is pretty strong, there are even more robots than in Germany, and lots of accidents. So I think what Anthony said is very important also in terms of like a human-centric production, to make sure that we are not short on workers in the factory, and making sure that we benefit from the technology what robots can help, and at the same time seamlessly work with humans, with workers. To design this kind of manufacturing is really challenging, and but I really can see that something is coming up. We have already robots on a small scale who can hold, let's say, 50 kilograms or 100 pounds or something like this. We can see that already, but in like full-fledged automotive or automotive companies, I have not seen that yet. So I totally agree. In the next few years, this will be ready for a big revolution in manufacturing. not just in US and Europe, but I think also in China and these kind of countries.
Yes, it has to be worldwide, or we cannot reap the benefits of any of the innovation that we are working on.
Um,
Charlotte, would you like to add anything
uh,
to that?
Gita, actually, I would like to just mention something because as I was listening to Anthony, totally agree
Definitely.
that we do have a lot of data, and we're gonna start making decisions based on context. But from my experience, so I kind of categorize all of these things with regards to like a transformation journey, right? Digital transformation. I think aside from the technology, I think business models innovation and also change management is actually very important because every company is at a different stage of, let's just call it, transformation maturity. Some they're just doing simple things, to improve, to reduce costs. Others, they're doing more complex things because they want to provide superior customer experience for their end customers, and others are doing even more advanced things to like create new business models. My point is the technology and the capabilities of the technology is important, but in order to really unleash the real power of, like, let's just say, the advancement of technology, we also need business models innovation, and most importantly change management, like for companies to actually change the way they do business. So just want to kind of share that perspective.
Absolutely. Thank you, Sunita. So, Yasser, would you like to add to that?
Yeah, sure. Actually, I will have two faults because thinking about human and robotic is where I love the fact that it was brought up by Anthony that I think, no, sorry, Kristen, that there's accidents happening and so on. What we gonna see? Let me start first. What we have right now, robotics in the manufacturing, it's automation. So basically, you set up the programming of the robotic. They do precise tasks to some degree better than a human, and repetitively and with limited error, etc. So your yield becomes higher, and your production quality is consistent. So the current, let's say, industrial 4.0 or whatever robotics that we have in the market is achieving this in a great way. Where we need to get to the next level is has um, yet to, in the next 5 years, I think we'll see, there will be extensive usage of available technology of sensing, camera, like vision, computer vision, decision making on the robotic side itself. So there will be more decision on the edge pushed out to the robotic machine that can do better job on what they're doing, but also avoid accidents and avoid the objects and the interaction with the in the wrong way. And we can see as a robotic on wheels, for example, the smart cars that have like autopilots, for example, and how they are in how many generation now, generation 9, 10, 11, and how it's advancing. And it's using the LiDAR, the radar, the cameras, and all this technology. You can see it in cars, you're going to see it in satellites, you can see it in robotics, in machines, in the even in the vacuum cleaner, like iRobot, for example. So the more you push decision making and smartness into the robotic, the more advancement use cases will happen. Um, so where the complexity will happen is that the more vendor providing these different robotics and robotic innovations, somehow you bring it all to the factory and you suddenly have different types of operating mode, different type of robotics that will operate differently. Then you need to centralize again how this operation happens. So that's where the strength of the cloud happens. So you have to have an OS for these robotic in the cloud, that all of these different vendors, all different types, operate in same manner. So you have common denominator of what the operation rule would be in a factory or enterprise or the streets. And if a company or a government or enterprise want to update certain rules, they go to one place and then that actually distributed along all different type of robotics. So the standards of operation becomes distributed. So the cloud for the distribution of rules has to happen. The final point I want to make is we need to not forget about human benefit of robotic. So if you think about the current robotic arms for the limbs, for people who accidentally or have some accident in their life that they lost some limb. Now you can see some of those robotic arms are able to allow these people to actually function. This industry, I think, in the next 5 years will advance very, very fast. That will actually provide even an eye, robotic eye, and robotic, some kind of a robotic movement for joints and stuff like that. So that will enhance the life of the human, and I see that industry will also grow because the principle of that is started for more than 10 years already, and now there's more sensors technology, more different battery modes that's available, and so on. So that's where I see the next 5 years for robotics and humans will be.
Thank you, yes, sir. You covered a lot of ground. It covered decision science, it's covered edge computing, sensing, human robot integration, and service robots. I think we have an expert panel here that can probably address all of that. But first, I would like to call on Shaolin to, she has spent a lot of time on the sensing part, the edge computing part, so she can add her thoughts. And then Yuki, who has spent like 15 years now working on the service robot side and enabling robotics to help people, help the society. So if you, Shaolin and Yuki can add to this, it'll be wonderful.
Okay.
Thank you, Geetha. I think already has been talked about the data and also the intelligence, edge versus cloud. And I just wanted to add two things. I think I personally was involved in robotics and the factory automation in TI's Texas Instruments fabrication facilities. And we do facing, I think first of all, put the wireless connectivity to be robust in the factory environment is one of the challenges. But I think we accommodated that. We get a robust wireless communication, which allow us put the sensors anywhere we want it to be. But now the challenge, I think we haven't put enough thought in the very beginning. What is the energy efficiency and the energy budget for the robot? Because the robot making decision based on a lot of distributed sensors in the surrounding, and these sensors not necessarily had the luxury of a DC charge in the next to you, so you can charge. So our sensors, very small, tiny sensor we're talking about, even much less than a penny, and it's put in the one machine, for example, put the 10 to 20 sensors, and they run out of battery sometimes within a couple of months, sometimes within 1 year. So how to get all these things synchronized? We need to really very well think through the power efficiency and the power budget that we're living with. And the second part, and also because we're in the early stage, we try to just collect data. We just try to see what's going on. Can we make sense out of a tremendous amount of data that we collected so far? Barely people start to think about the security part of this. We'll know we have a physical security as well as cyber security, and also the security sometimes contradictory to the embedded work, right? In order to do the security, I have to add a certain amount of overhead. My communication bandwidth is already very limited, but I have to do a lot of other security related traffic. So how we fan all this into a holistic decision making process at a very early stage is very critical to the success of our journey down the road. That's all I want to add.
Yes,
Great,
hard
great.
topics actually that probably will take more than 5 years even to solve and integrate. Yuki, would you like to add something from a service robot perspective?
Yeah. So that is a very very interesting story about for future 5 years. But 20 years ago, in Japan we started life with robots. So 20 years ago we showed Asimov that bipedal robot in the museum. In the science museum, showed such a robot show in the 20 years long. So that's a starting point, and we have so many robots in the 20 years. Right now, we have an Aibo that an four-legged robot like a dog. It's a very very famous dog robot in Japan, and that robot has a very very good in the hearing system, and a sensing system inside a small body.
Let us move on to the next topic. Um Augmented reality, AR,
Mhm.
was one of the topics that everybody voted on. So maybe we should have a discussion on that. Who would like to go first?
Well, I can go first if you want.
Sure.
Well,
Go ahead,
augmented
George.
reality. I'm a mechanical engineer by training, so I'm not so much into the software, not so much software expert. But I saw that the last 10 years or so we talked a lot about augmented reality. But when I recall what Sunita said about the business model, I have to say that it never went out there, and that there's no sustainable business model available for augmented reality technology or companies who make money with it. That's at least my perception. But during the pandemic, I saw two things. One was I was reading an article from Michael Porter, professor at Harvard Business School, a strategic professor, and I thought, like, if he's writing something about augmented reality, then it must be serious. And the second thing was, during the pandemic, we all had to stay home, but at least here in Austria and Germany, machine factoring companies, when they had to service their machines and couldn't fly there with an airplane, they started to help out with head-mounted devices, virtual reality, augmented reality things, and all of a sudden, at least in preventive maintenance things and or maintenance things in general, this kind of things all of a sudden got into the industry. And what I see recently is being involved in one of those startups. I see that, for example, the fashion industry, when you buy clothes and you cannot go to a shop, all of a sudden, you do online shopping, you buy clothes from all kinds of companies online, but you only see, the front or the back, and all of a sudden, augmented reality also here with virtual try-on, all of a sudden, this is a new hype where I can see that maybe not next year, but in the next 2, 3, 4 years, this technology might be part of our online shopping life. I know, at least from some companies like Amazon, or tech companies in Silicon Valley, are working very hard on that, and I think we are close to breakthrough. We are on the edge, I think, on that topic, that this is actually a business model which helps us to reduce return rates, show clothes on your body naturally, not looking like a cartoon, but really in a good quality. So that's why I think this is coming soon. I don't know how much that involves how that works in the traditional manufacturing engineering companies, but in terms of fashion, I can see that something is coming up.
Thank you. So you think there is at least one business case? Yes, sir. What do
Yeah.
you think? Can you make a case for more business cases?
Oh yeah, yeah. And so augmented reality, the first time we've actually got into it from research and development is probably more than 10 years ago. And it was based on a smartphone and map. So back in Qualcomm, Dr. Paul Jacobs, the son of the founder, he um, he created this project, which basically you bring, it's the camera, there is GPS in the camera and the phone, the smartphone, and you go you look at, for example, a, like a position in the street, and it will show you like some information about the shops and stuff. So it's kind of like give you a live map rather than just a regular map. So that was the beginning of it. And then it wasn't a great attraction for business, of course. So it's the quality, the speed of there was no 4G or LTE. It was on 3G. So but what I think we've seen and before the epidemic, when I was in China, in China Telecom, actually they have a museum, and the training was the first use case that was really really solid on the augmented reality, because what happened is the teaching of the mechanics or the tool operators, they cannot get the right instructions from either the books, or they don't have the instructor for the tool that's from Europe, for example. So they invented this usage of the augmented reality training while they are working. Then there's arrows and some instruction in Chinese comes in the screen, and actually as the worker get trained, they know exactly what they are touching and where to go. And that's before the epidemic. But after the epidemic, what it and I want to hit the sustainability and the remote learning and working. um, what forced the more innovation is the learning. So schools, remote schools. So suddenly you're able to have science lab for village schools that cannot afford, for example, to even have a building for a school. So down in the middle of some really poor villages anywhere in the world, um, that let alone they have building, they probably have a shed or something, and then you have the XR basically viewer with the students. They can actually work with lab equipment. They can see it around them and so on. That would actually push this technology to the learning area, and for meetings, so the mobile work, so less emissions, less driving, is in the office conferences, and I've seen many companies actually doing a lot of development of that, is to actually have meetings with real augmented reality with team whiteboard and so on. So in the next 5 years, this would actually increase because now more and more companies and enterprise seeing the benefit of remote working, and they will enhance the tools to actually get that work done better. And that's the AR is one part of that.
Thank you. So, that is certainly a case to be made for learning, which can be immensely improved and made more active if you have a AR, VR enabling that thing. UK, you come from the education world. You use your robots to teach schools, to teach university students, train people. Have you used AR in your training systems in addition to your robots? What is your thought on this?
Yeah, my experience in an AR and VR and for the education, so through the network, uh, we teach the robots with a simulator, and they operate from through the internet. So student in the home and then operate with an AR or VR system uh, and operate a real robot with in our companies. So that's very interesting. Sometimes networking delayed and the robot is not working. But after that, they run something what is the communication with a remote system and so on. And the other side, we use an AR system to teach the robots. So robots need a teaching system, and then we make an AR system with a robot like a digital train, and simulator is a robot, and the real images in the simulator, and the robot takes the image and to uh, make a image and word in the simulators. So if they put the image and then recognize something to pick, and simulators robot and pick such a virtual but real things. It's very, very interesting. So maybe 5 years later, it is very normal. It's a very cutting edge now, but after five, maybe it's very, very popular, I think.
That's very interesting. Training a robot using AR. That's the first time I've heard that. Very interesting concept. Any AI system is only as good as the training it receives.
Mm-hmm.
So that's one aspect. And the other aspect that Yasa mentioned was getting AR to educate in areas of the world where you don't have access to too much of technology. But to be
Mm-hmm.
able to do that, you need good connectivity. And so on the technology aspects, for something to like this to be actually impacting people, we come
Mm-hmm.
back to the connectivity question. Shaolin, can you add anything to that?
And I just want to add from a user, I'm a user of AR VR perspective. I have a Peloton bike. I always use the scenery ride because I like to, ride across Europe, whatever interesting location. I cannot wait to see in the next maybe 1 year even have an AR or VR allow me feel like I'm really riding in the place and also see my, other riders we can interact. I just cannot wait to happen.
That's very cool. That's very cool. So, Nita, do you want to add something to this?
No, I think people have mentioned a lot of the use cases, but kind of like maybe emerging that I saw was kind of interesting. So there are companies out there who are trying to do 3D representation of people, and the use cases are usually like retail and conference, and I have actually tried one of them, and like you have like this kind of 3D hologram in front of you of the person that you are conversing on a conference. And I thought that was like, wow, that is really real time, and it looks like that person. And I thought like, wow, just the advancement of the technology is really amazing.
Anthony, do you think this will impact an area where you are passionate about, where you enable robotics and humans to coexist together in a factory environment, in an industrial environment, and work safely?
Yes, I think it'll contribute significantly. I wanted to share a use case. Well, first a perspective and then a use case. So first, I want to separate AR and VR a little bit because they get talked about
Together.
together. Whereas I think AR has a very different set of use cases than VR. And a lot of AR, let's call it AR light, what you can do with phones and tablets, I think is actually already starting to become pervasive and will feel natural, and we're going to just start taking it for granted. Obviously things like Pokemon Go or swept the world, and we now just take it for granted. It's just a game. We don't even think of it as AR anymore. So the use case that I wanted to share is part of how we do development on our robotic systems internally is we actually use AR to view what the robot perceives about the environment in context. So anyone who's built robots, has spent a lot of time in front of 3D representations and simulators and all of these different tools so that you can see what the robot's thinking, where it's planning to go, etc. But internally, we have tools where you just actually look through a tablet and you project on the floor where the robot's going, where it thinks is up, where it thinks it's oriented. And that has shortened certainly development time for us. So for me, that's just one example of, AR is just a tool, and we're starting to be able to use it quite easily because every phone and tablet now has, AR kit or AR core or just, these different ways of developing using AR. And in some ways, it'll just start permeating what we do on mobile devices and not even be thought of as AR in some ways.
That's wonderful. Could you add anything about the AI aspect that goes into the training? Would that be helpful in this field?
Sure. I mean, and for that, it actually, leans more toward VR. But this just piggybacks on the example that Yuki talked about, and certainly lines up with my experience. We actually do use simulation and, simulating things in 3D to augment the things that we use to train robots. So I think it's been a strategy over the last few years for machine learning, especially when you're building systems that operate in the real world. We use a combination of various types of data, both 2D data, pictures, etc. And then we actually also use simulation to generate training data that we can also use for the robots.
Thank you. So this has been an interesting discussion where we talked about training not just humans. AR and VR helping to train not just humans but also robots themselves. It's almost completes a closed loop ecosystem where we kind of learn from each other. And I guess all of this has to start from the design aspect, like Christian mentioned, and start from the beginning, and then it helps the ecosystem. I think we are at the end time for discussion for the 5 year topic, and we will then go on to voting on the second topic. So this has been a very lively discussion on near-term innovations and their implications. So let's think about what will be the most challenging information that will disrupt the market in the next 10 years for Industry 5. We have the link on the right hand side as before. So if you can bring that up and give your choices through the vote. We have the choices coming in. There's simulation technology. Oh, there's quantum computing, democratize AI, brain inspired computing. Very interesting ones. Metaverse again. Have any more? We have some more time. You can add a few more. All right. So the poll is closed, then let's probably start with a topic that we have not touched about. Um, Democratize AI. Very interesting concept. Who would like to take that first?
Okay. So, yeah. Yeah. Right now, democratized AI is a very famous AI boom, and but that 10 years later, right now collaborative robot is growing up, growing up, growing up. So maybe that parts and modules and sensors, sensor fusion, and many things will be very popular in 10 years later. So that democratized AI is for the software, but 10 years later, I think such modules are very popular in the world. So before the AI boom, and then we have a maker boom. So according to that, maybe a software boom, and after that, a hardware boom, I think. So it make an democratized robotics and the AI. Yes.
Would you like to add something about the last mile and the last hand?
Yeah. So right now, many experience in the last 1 mile, and many transportation is developed and realized to what how they to deliver the passage something, and so last one hand, so maybe it's a very not a popular word. I introduced that in the belt conveyor in the factory. Many people working for the last of the belt conveyor to check something or put it move to belt conveyor and belt conveyor, such a operation. So that is a bottleneck of the production. So maybe that will be take over with an robot and the AI. So that is I named the last one hand, like a last 1 mile, and maybe recognition system will be growing up in 10 years later, and also manipulation is more precise. Um, Fine operation maybe they realize. So such a generation, last one hand is solved AI and robotics, I think.
Christian, what is your take on the effect of AI in this Industry 5 innovative solutions and simulations?
Well, simulation, I think this is really something what in manufacturing we see already to use simulation for increasing efficiency and so forth. So I think that like the this kind of simulation is already done, but I think what I recognized is that there are other kind of simulation going on, uh, which uh, which we cannot think of today. Simulation of human behavior, simulation of this whole sustainability. issue. What happens when we do something? What effect has that on the on our environment? I think there's a lot coming up to in order to make better decisions. In terms of artificial intelligence, this is a topic I'm not very familiar with. My students do a lot with them. I'm the professor, but you always can learn also from students.
Yes.
I just think this democratizing artificial intelligence, I think this is really important that everybody can use this tool to work with machines and get better results out of data. Um, I think this is fascinating, but I think there are others in this panel who can explain that better and have more experience on that. I think so. I want to give that back with the question.
Anybody want to take the next lead?
Geeta, I just want to kind of like make a comment based on some of the work that I did when I was still at HP 3D printing. Maybe it's more of a out of the box applications and business models that are enabled, with the new technology to democratize everything. And what I meant by that is one of the things that we were thinking of is that one day it would be possible to actually change, the way kind of like people buy, let's say running shoes or orthotics and prosthetics by enabling them to like upload their body data. They scan it with your phone, you upload it, and then there will be a new system where based on AI and all that, the machine would understand what is like the best shoes for you, based on your gait, your body data, your running style and things like that. Make it this in distributed manufacturing closer to where the demand's here, and ship it to you in like 2 3 days. So my point is more like in 10 years, like maybe there will be very innovative, new disruptive business models that are enabled by all this technology, by AI, by 3D printing, that will democratize everything. Because in this case, right, there is a new paradigm where people can actually buy things by just uploading their data, and then the thing is made just for them and come in 2 3 days.
Very interesting thought. So this is along the lines of using AR VR for trying on dresses. Here you're using AI-enabled technology to make the decision for you. I'm not sure at this point how many people are comfortable with a situation like that. So, anyone else in the audience who wants to add to that?
Yeah, can I? Oh, uh, Shalini, can I speak?
Go ahead,
Yeah,
Yasser.
yeah. So the ambitious, as technologists and the people who wants to see technology advance quickly, we have an ambition that the use of data is beneficial. People really go at across the board to try to share, and that's why we have open source software. We have all these boards where you can contribute code, etc. But when it gets to data that's collected and using it for artificial intelligence, data becoming the new oil, a
Yes.
new currency. So you you have an ambitious crowd that wants to reuse everything globally, but then the people who invested in collecting
Yes.
such data or storing it and maintaining it feel the right. By the way, I'm in the edge between the two, so I'm not saying who's right, who's wrong here. I'm just putting the data in front of us. There is a reality that the owners of this data will regulate how it's used. You can use it by paying them money or royalty, or you have to be national to use it. So you'll have governments who segregate the data for themselves and not allow. And some companies also protect this data collected because that's actually asset. Data is an asset. Knowledge is power, or what we say, right? So we need to make two things in our planning when we are advancing in technology. First of all, we have to educate the type of data we're talking about.
Yes.
Like, for example, I have a recent, I'm not going to bring names or government or anything. I have a recent discussion with some government that they want to block all collected data to create AI from it or anything. And I said, okay, so why you care about how the tires heat up, for example, in your road? So if Bridgestone or Goodyear or something wants to collect all this data and the analytics of the data to enhance their product globally, if they are operate in Sweden or they operate in the Sahara. I mean, they really want to get that. Why you segregate that? Why you not allow this data to be shared? So that needs education. So you need to sit down with these regulators as well as the corporates, like big corporates who have data, and say this is beneficial to the human, to the environment, to sustainability, that this set of data needs to be shared and need to be democratized. Good. So that's education. Second thing is we need to make the data collected or even the result of the any analytics categorized. So we have personal, we have geopolitical, we have strategic, but we have environment, we have health, we have sustainability. Somehow data scientists need to start categorizing data, just not make it as a meta file data. And we got picture of everything and everywhere. And let's categorize these collection of things so it helps regulator or enterprise to understand what they can allow, what they can't. Right now, you have black and white. You have it's a binary. Like some companies or government, either completely open or completely closed. And you have some in between, but it's they're struggling to understand. So that's I think what we should do as technologists to start educating more about the type of data that is being used, as well as the category of the data.
Very, very helpful discussion, Yasser. So essentially, what you are talking about is the need to dissociate all of the data that we collect from sensors for an industrial or an application mode to that we collect from people. And there has to be a different governance for one, which can enable all of society going towards this industry 5, as opposed to the other, the personal data, which needs more safeguards.
Yeah, and the word using AI democracy is very very big and beautiful, but it will confuse people. What do you mean? Do you want to take my own? How is my shoe size, for example, public? That's the issue that people will be faced with.
Makes a lot of sense. Anthony, do you want to add?
Sure. I really appreciate Yasser's comments about curation of data and being able to really, in a fine-tuned way, understand the categories that data is coming from. I think there is a piece about democratizing AI that I think does bear really strong resemblance to the open source
Yes.
software movement. And while there is going to be a lot of government regulation and a lot of protection by corporations, because this is a valuable asset, I do think in parallel, there will also be a lot of movement to build data sets that are generally available. We see this in academia already. And I think there will continue to be a trend toward AI being more available to more people. And I sometimes say that, from my perspective, what's exciting about AI now is it's not that deep learning is fantastic at what it does for the first time. It's actually been a fantastic tool for almost a decade. What's different is that a small team or an individual using publicly available data can build world-class classifiers or recognizers or arbitration systems with the resources and computation that a single person or a small team has access to. So it's that AI has kind of gotten to the garage stage where computers and chips were in the early 80s, so that very small teams can have a really big impact on the frontier of what's possible. And I think for me, that's the piece of democratizing AI that I think is really important about where we are now and is kind of unstoppable.
That actually makes a lot of sense. Actually, we saw a revolution of this kind happen not too long ago when in most of the developing world, if you had an infrastructure related to a technology, it used to be very hard to get it adopted. Case in point being the cell phone. So as soon as it became an airway, well, you didn't need an infrastructure, a tunnel being dug, a road being laid. It reached everybody, and that then opened up the ecosystem to so much of innovation, whether it is trading for grains, whether it is getting information about the prices of grain. So it has beneficial impacts that we don't imagine initially. Whoever thought that a smartphone would enable all this? But then there are also these concerns about personalized information that one has to safeguard. Makes a lot of sense. So we are almost at the halfway point of our second discussion. So maybe we need to move on to a second topic. And you had brought up two interesting during the polling, two interesting topics. So one was quantum computing, quantum sensing, and the other one was brain inspired computing. So I will include both, and just feel free, whoever wants to join into a discussion for the next 15 minutes, go ahead.
I can start maybe. Actually, I was thinking about the next 10 years. I was thinking at the quantum computing at the beginning. And then when I think a little bit more, I think this brain inspired computing might be more broad applicability, actually broader than quantum computing. The reason is being we all know the conventional computing is already approaching its limit in the energy efficiency with the continued growth. We talk about AI, VR, AR, all these requires cloud, requires tremendous amount of computing power. And we're talking about maybe year 2032, we are going to need the computing power grow about 1,000 zips. Today we're talking about MIPS, flops, but the zips is zillion instructions per second. But on the other hand, the power acquisition of the whole universe is actually stay flat. So you'll see a big saturation, the chip level energy per bit, even though in the past 40 years it's decreasing dramatically, but we're reaching the limit of Moore's law, as you know, because of the physical theoretical limit is close. So in order to do that, I think we have to really change the way we're thinking of computing, which is very serial, right? Memory input output. And it's a sequential, serial, very fast speed computation model versus in the brain, we are process a tremendous amount of neurons in parallel, and then you basically process that way. And just to take a human brain, it is estimated when you perceive something from outside world, the actually digest the bit rate is very slow, which is about 200,000 x of reduction of the signal you saw from the outside world to the actual signal you use to process inside the brain to make a decision. So this is so important that it is time to change. And basically, from a viable commercial new computer perspective, we see a fundamentally different computation model, and which will require a lot of technology, development, and including, quantum computing is part of that, and also the energy efficiency and the parallelism. And there is, when we say brain-inspired computing, actually, you hear about the word called neuromorphic computing or in-memory computing. All these are extend the parallelism, really a huge dimension of compression and how we generate, while we'll generate some conclusion at the same time we're processing, we're seeing from the outside world. So that is my pick. That's why I sort of switched from quantum computing to brain inspired computing.
So just to add on to that, so we have two. We have the software aspect of this, and then we have the hardware aspect of this. So we have companies that are coming up with AI chips that can handle this massively parallel learning. And then you also have the computing side where you have neuromorphic computing. From your experience working in TI for so long, do you see one or the other take the lead at present? And where do you think it will be moving forward in the next decade? Which will take precedence?
I
Roman?
see quantum will never replace the classical computer. It will be a complementary on the existing classical computing model. For example, quantum, right? With about 300 qubits, logical qubit, you're able to actually do the combinations of the whole particles in the whole universe. So but they can only limit it to certain type of computation. Not to mention they still have technical challenges like the temperature, right? The vacuum environment it has to be sit in. So it is a complementary and also neuromorphic. It was started at the beginning and complement the classical computing model, and incrementally people will see the advantages of neuromorphic, and maybe that one has the potential actually to replace the classical computing. That's just my personal opinion.
Anthony?
Yeah, so I really appreciate your comments, and I'm just going to build on it a little bit because I agree that quantum computing is just one example of different computational paradigms that I think have the ability to really disrupt what we're doing. You know, the reason that I think quantum computing is an interesting example and an important one is um, quantum computing allows us to solve different types of problems or problems that are extremely hard in the current computing paradigm. You know, one of the things that we talked about when we started was the importance of making multi-dimensional decisions based on a lot of complex inputs from all these sensors that we now have access to and all these inputs into every process, you know, whether it's within manufacturing or you know, even at a policy level. And different computing paradigms like quantum computing will give us the ability to solve some of these problems, you know, if their value, you know, really comes to pass. You know, so a classic example is it's really easy to create optimization problems, you know, simple things like routing lots of vehicles on streets or routing lots of robots in warehouses. It becomes
Yes.
computationally intractable actually quite easily. You know, as humans, we look at it and we think, oh, well, it should be obvious that we know where to tell all the robots to go. But anyone who's actually done the software to do this realizes, um, you know, these problems grow in complexity, you know, geometrically at a minimum. Um, you know, paradigms like quantum computing hold promise to give us solutions to some of these problems in a finite amount of time. And I think that allows us to solve really hard, complex problems, you know, much more tractably, and therefore, again, opens up the opportunity to, you know, do some of these hard things.
And I just want to add a little bit more on top of Anthony's comment. I really, truly convinced it solved the problem that nobody else is able to solve, or we cannot even picture we're able to solve in the future. But quantum computing also is a double-edged sword, in my opinion. One of the characteristics of quantum computing is good at, if it's a short capable, right? It's good at do the decrypt, the encryption, really break the encrypted data or break the whole security system today we're built on top. And that is why NIST actually, I think 2 years ago, they put a call for proposal, how to deal with, assume quantum computing is here, how we deal with the security. It's called post-quantum security. So because we have to prepare for that, and the quantum machine can easily break the security system that we build, the crypto engine and all the algorithm we built upon in the last X number of years. But all of a sudden, it will break because of I just want to mention there is some,
That
post-quantum security that we have to worry about.
very, very valid point. So, yeah, so would you like to add to that in terms of security? And you have data that's stored on the cloud, and that includes personal data, data from so whole lot of sensors. How does one deal with something like that, especially when it comes to Industry 5, where you may have very critical infrastructure that depend on this, and now you have a enabling technology that enables a whole lot of progress, but comes with some really, really scary disadvantages too that can be not used when not used in the appropriate way.
So my position on this, as actually Anthony mentioned, it's one of the methods of computation that would be enhancing our solving very complex problems. But let's focus on the quantum computing itself, where it is right now. In my opinion, and where the research is at, I think we're gonna see a lot more of development on how the quantum computing would be used at scale. At the moment, it's mostly in used in certain applications like the weather and some difficult routing of airplanes or something like that. But to use it for, let's say, even enterprises to break passwords and these things, I think it's still far, but there's a lot of research happening and will happen for the next at least 10 years. I predict another 10 years we will continue to see more functionality as well as capabilities, but also regulations on what exactly will go onto the capability of these computation models to prevent such acts. Because thinking about the bitcoins and what the digital currency would go to, what that means if quantum computing can actually solve these combinations much easier, and can, you never know what the end story would be with some people collecting multiple millions because of those bitcoins. So I think more research is happening. Can I but I want to just go into this topic of simulation a little bit before our time ends here. um,
Please do. Yeah.
yeah, I think there going to five, to the industrial five, I think more and more usage of a simulation will be a must. And we will see more simulation. So we're talking about the next 10 years. We'll see the technology of simulation become as close to reality as possible. So right now, if you do simulation running, it's kind of like you're thinking 50-50 chance that you'll hit the right modeling, and you have to verify and verify again and so on. I think the more we bring the simulation technology to work with the data, with the AI, the more realistic models will come to happen, and that's what is needed for digital twin. More and more, you'll see a lot of things will be planned using digital twin simulation before any project get put in place or any change have happened. And even at maintenance monitoring, there will be much more advancement in digital twin that will allow more efficiency in how to deal with environment, for example, like oceans. So we are harvesting energy from ocean. I'm not talking about the oil and gas, but particularly like waves and wind and all those things. You need to have a digital twin to and simulation to see the impact on environment and the ocean life and so on. And I think this is an area where the companies are investing heavily, and will have who invests right now will have a huge advantage over their peers actually, because they're taking the time to get used to using these technologies and putting it in their own operation as a normal way of work. I've seen digital twins that's happening right now, like people are using digital twins, is really far from reality, and it's some kind of cartoonish. But I think today there will be an announcement from our company that actually there's a new way of thinking about digital twin, but it will be part of the advancement in simulation that will include 3D, will include probably quantum computing later in the decade. We don't know. Yeah.
Thank you. Twins, whether it's digital or otherwise, is really interesting. So your point is that digital twin currently is not trained for specific use cases. When we start putting it into the specific use cases and specific ecosystem, whether it is harnessing energy from waves, things where it becomes difficult to go and actually get the data out, it can have a great impact. I think that's a really wonderful thought, and let's hope that in 10 years we move along all of these cutting edge technologies where it can actually impact society, whether it's a brain inspired computing, whether it's democratizing AI, simulation, quantum computing, as long as it's benefiting society and it's helping everybody and it's not just a niche that helps a few, I think we should all be clapping for it. So we have had a really interesting, simulating, uh, and happy exchange of ideas. It's now time to open the floor for audience discussions. And so uh, now is the time to get your phone ready and scan your QR code or have your browser ready as you will be able to vote on the topics provided by the panelists and let us know what you think will be the most impactful and the disruptive. As you see the QR code come up on the screen, you should also be able to find a link in the chat section on the right hand side of your screen to go to the polling page, and you will be asked what industry. So, this will be the first question. What industry sector are you joining from? That will be followed by a new page where you can vote on the panelists' responses to question one and then to question two. So, let's see what's coming up. That's really interesting. So, the split, it's moving fast between industry, startup, and investors. And this has been kind of constant across the 4 days that we have had. We have far more participants coming in from industry, and then you have a lot of participants coming in from startups. We are all discussing cutting edge areas. Hopefully, they are all working on these cutting edge areas. Oh wow, we have government and nonprofits too joining now. That's wonderful. That's cool. We have 5 more seconds. Oh, wow, that was interesting. So, industry takes the lead. Okay. We will now move on to the question that you want to vote on, the audience responses. So let's see how that is going. Which is the most impactful innovation that can be realized in the next 5 years? Distributing energy manufacturing, smart sensing that has now picked up, and robotics and human integration, augmented reality. So the lead is smart sensing. Do scan the QR code to provide your answers to the next 10-year question. So we have brain inspired computing, democratized AI, that takes the lead. Metaverse, so we have an almost equal split between brain inspired computing and democratized AI, an equal split between simulation technology and quantum computing. But the second lead topic is metaverse. That's very interesting. Thank you, all audience, for the poll. And also, could the mascot that we had discussed in the beginning of the session is called Nico Tencho, and it is a mascot, a master. It's a bipedal robot it Yuki uses for teaching and training. You may want to type in the chat what you think that mascot is. What kind of an animal is it? Just to keep the interest going while we start discussing the 5 year and the 10-year topic with our panelists. So, panelists, let's take the floor and let's have your thoughts on the 5 year question first.
Okay, and Neko Tenchos. Yeah, so we make that cat robot for the mascot. It's 10 years ago. So it's at that time it's a very famous robot Asimo is walking and running, and we also make such a humanoid robot now. But now we make a food picking robot right now. So that is slightly different. Mascot robot is very familiar and very cute. So that is five, not 5 next years, but surgery past, I think. So next 5 years, 10 years, uh, we think we work with robots. Yeah, and the collaborative robot is more growing up. maybe arm robot, humanoid robots, uh, many robots appears in 5 years, I think.
Shaolin, do you want to add anything about the first 5 year question that people had voted on about smart sensing?
Absolutely. Actually, I'm so glad the smart sensing is being voted number one. Yay. And I think, the smart, we're talking about smart society that is happening. And it is actually expected by SRC, which is the Semiconductor Research Organization, that is about 45 trillion sensors will be installed during that time. And we're talking about the data of one, they call the Bronto byte, BB, one BB, capital BB. And also the data comes in is we're going to basically will face the big we call the data deluge problem, right? It's not just data, actually, it's an analog signal. We're talking about the analog signal here. So with that, and I already talked about, the human brain is able to do the compression 200,000 x to 1 compression. So the semiconductor or the sensors we're having today is really not nearly. It's just doing still at whatever sampling frequency. We dump the data into the memory and then do filtering, FFT, and all that. So I don't know how far away from the human brain, how they do the sensing versus how the electronics today is doing the sensing. And that is what we call sensing to action and or smart sensing. So this kind of, I just want to call the action here really to reach that goal, and how we measure our electronics is doing, really how fast we're able to do it and how fast we're going to compress from analog signal to information. And are we able to, let's say, human brains do 200,000, maybe we target to 100,000, half of that compression. So the technologies inside this area really sensing to action. We're talking about the sensing and the processing, maybe even in the analog domain for the processing, or something called analog AI. And also, we already mentioned about brain inspired neuromorphic computing, and a lot of perception related algorithms, approximate computing, energy efficiency in memory. All it's so critical. Really want to call an action for both industrial and investment space. See, this is an area for investment for sure, as well as call for action for the students, maybe the students in the engineering domain to pursue more on the analog electronics. The world of analog is not finished yet. It's not even started yet. So that's
Mhm.
all my comment.
That's very interesting. Who would like to take this discussion next?
Can I actually? I want to tell Shiolin probably some good news. Actually, the industry listened, and I have to share this with you because it's very exciting to me as well. So thinking about the sensing, it can be very passive, like as you said, analog, like on or off, or like I'm burned or not. But actually, the industry moved, I would say, in the past 3 years, very quickly to smart sensing. Now we have sensors that does preventive maintenance flagging. So one of the most difficult maintenance that we have is remote maintenance, like for example, for the wind farms, very expensive, and for machines that are remote. And it just combines a lot of goodies, so I have to mention it. So there's this smart remote sensing that one small company in the Bay Area, Shoreline IoT, it's called. They did like small device that you can carry it on your hand. It doesn't need the technologists to actually put it on. They have a box with a glue, and anybody can just put it on the machine where like engine or something. It has
Mhm.
connectivity, Wi-Fi or 5G or 4G, and it have one tops AI machine learning, and it learns how the normal sound, and then when there is some kind of a different sound, it start to put the flags on and send out the data to the control, whoever is controlling the maintenance. So that's a smart sensing that we're starting to see. And there's some pioneer companies like Shoreline IT, as I mentioned, but we see it in others, like preventing of fire. So there is in Brazil, I saw like some sensing technology where the jungles, like when they go on fire, you want to prevent that from happening. And there's these sensors that if it sense not the heat because it's hot, it's tropical, but actually heat with smoke and wind, and start to operate the cameras and put the cameras on the direction that the sensor is sending to give the like ahead of time signal, so there's a fire, so people can go to it, cut the electricity, etc., etc. So it is moving, and it's going to move fast. And the more data we collect, the more smartness these sensors start to happen to take.
Yes.
Thank you. Yes, that's really interesting. So, condition based monitoring, not just in a factory setting, but also for ecology. That's wonderful. So, Anthony and Christian, would you like to add to this?
Sure. I would love to put a fine point on the comments made by Yasser and Xiaolin. What I think is wonderful about the trend that I'm seeing in smart sensing of essentially putting compute power right next to a sensor or a set of sensors is that we're changing from data flowing to systems to information flowing to systems. So instead of just getting a temperature reading or whatever the sensors, measuring kind of naturally, you can actually determine something like, is there a hazard? And that distinction between data and information, I think, is extremely important. The other effect that has is the amount of network connectivity that you need goes down dramatically. Because instead of all these sensors streaming, whether for video it's gigabytes per second, or for linear sensors it's megabytes per second, you're sending bits per second. You're just saying, are things okay or are things not okay? And for the amount of sensors that we see proliferating, this has to happen, because we actually don't have the bandwidth to have 10 trillion sensors all sending raw information across the planet. That just actually wouldn't work. So I think this trend is necessary and positive in both those dimensions.
Maybe I would just add one more. I think smart sensing is so closely tied with the power consumption. Took a Yasser's example. Actually, we did a similar example. We have, as mentioned, we have something called penny sensors stick on anywhere in the machine in our fab today. And we did a test, actually. We started with, say, we do vibration sensing, right? The machine vibrates, so we want to see what is the signature of the anomaly. We started to say nobody knows, so we basically streaming raw data, and our penny died in weeks. So when we start to do, because our sampling frequency is about 10 kilohertz. If you calculate how much data we're spitting through, and the wireless is USB or Zigbee. So if you think about it, just died. And then we start to add in some thresholding, and we try the autoencoder algorithm. The smarter it gets, where we are today, we're very close to 1 year. This is just one example show how smart sensing is able to enable us to deploy.
Well, I have to add to that, our students, when they get projects working with industry, so every year we get a task from industry, and a group of students, 5-6 students, mechanical engineering, software engineering, electrical engineering, should solve this task and come up with a prototype. And I have to say that half of the projects has to do with smart sensing. I just have to think about, vibration in paper machines, producing paper, for the various machine parts, but also pipelines. Recently there was a student group coming up with oil pipelines. They are very long, and traditionally people have to walk along the pipeline and see if this is rusty or if everything is okay. The students came up with a smart sensor where nobody has to walk anymore, and you can do that with what Anthony said, with low bits. Every once a day something is transmitted, and so I think the students are extremely creative with coming up with new solutions where smart sensing is a very important part of all kinds of projects, what we get from industry. If these are pipelines or vibrations from paper machines or other sensors which are important to get an idea about preventive maintenance, to support that, and these kind of things. Even energy harvesting, there's a company, for example, who asked us, how can you get energy out of a car when a car is shaking, the suspension, so everything is moving? Can we get out energy of that movement, even in order to get some energy for lighting or something? So students are extremely creative, and I must say that the future is in the hands of our students. I'm already too old, I would say. So the young people
No,
are
you're not.
extremely creative and come up with very cool solutions. And that's when I think about, for example, metaverse. This is something I cannot even think about what's coming along the next 10, 15 years to us. So this is about the young people getting educated well at our universities all over the globe. And I think students are the future of the smart sensing, at least from my point of view.
Very true. Very true. Who would like to go next? Sunita.
Yeah, so I want to just add to that. So interesting that Christian mentioned industries, have all these projects about smart sensing. So a few years ago, I was with Siemens and, focusing on their industrial IoT for smart grid applications. And Christian, I think like industries are interested in this because, like there are business benefits and customer benefits that they can get from, successful deployments, right, of smart sensing use cases like predictive maintenance and all that. But I think what's important for a lot of legacy business that are mostly hardware focused, companies like Siemens, GE, Schneider, these are all, traditionally hardware focused companies. And they want to actually move up the value chain to be able to offer new business models like, technology enabled services business models to
Mhm.
offer predictive maintenance subscription because it's better for their business and it's also better for their customer, right? And so I just want to kind of like mention that all this great technology at the end of the day, each company, depending on who they are, where they are in their journey, what they want to use it, like they kind of like leverage it in order to either move up the value chain from a hardware trying to be offer subscription and services, or from the customer perspective, it also makes the customer more efficient and be able to be more reliable and resilient.
Especially the CEO of Siemens, Roland Busch, he visits our institute quite often. I was amazed how much they go into digital and they increase the value chain and what they do. And they want to grab the students in order to get them to get the new ideas and this kind of not old fashioned, but companies which are hardware focused. Very interesting, Sonita. I really can support it.
Wonderful. So we actually are almost at the close of this session, but I would like your opinion on the 10-year question, which was tied between neuromorphic computing and democratizing AI. So maybe we can just have a very short 2-minute discussion on that. Who wants to go first? Yes, sir.
Well, I
Oh, Shalin? Yuki it was. Sorry.
Okay. Democratic AI. I think more popular in the 10 years. So, as you know, computer has many progress in the 10 years or 20 years. That is a very high speed, I think. But on the other hand, robot has a mechanical system, so that has a slowly like a snail's progress, I think. So therefore, using the hardware like robots or sensors, they need a body. So body requires a special AI. So we call that AI in a physical computing or something, physical AI. So that is a very cutting edge now. So in 10 years, I think physical AI is focused on the research topics for the robotics field or an AI field. So AI and computing is focused on deep learning in the past 10 years, but the next 10 years are focused on physical AI, I think. So because they can researchers focused on the such AI because robots behavior is very very complex. So for example, imitation learning or from the humans. So humans train the robot within their behavior. So robot watches human behavior and it's learn something from the behavior. So after that, the robot imitates the motion or the performance of the human in their bodies. So that is a very very complex and algorithms to translate from the vision system and kinematics and how to decide on to make a performance something. So it's very very complex and exciting AI, I think. So that's why I think that 10 years later, domestic AI with a body, I think. So what do you think other panelists?
Very interesting. So for a
Maybe
robot to
I will
move,
just add maybe a couple of opportunities in the brain-inspired computing area
Yeah,
for
yeah.
people to think about. One is realize the properties of online adaptive device with some brain-inspired learning algorithm. The second one I was thinking is like achieve brain-like connectivity because they need to connect to one node, need to connect maybe thousands of neurons. And the third area is neuromorphic hardware. These are the electronic circuitry, which really mimic the biological structure of the nerve system. And the last one, but not the least, is we call the spiking neural network, SNN. Those are potential areas to pursue further.
very interesting. Thank you, panelists. This has been a wonderful discussion on the votes by our audience. But now we will go to question and answer that the audience members can ask. So the next half an hour or so, we will open up the floor completely to our audience. Dear audience member, please feel free to post your questions in the chat section and we will take that up to the panelists to respond. Do also give your opinion on what you think their mascot is. It is a panda? Is it a cat? Is it a teddy bear? Put those things in. We'll have some fun. We have a question from Georg. Many of the concepts discussed today, like AI, AR, smart sensors, are already applied in Industry 4. So, what makes the real difference between I 4.0 and I 5.0? Very nice question. Who wants to take it up? So, let's have this as a pre discussion. Anyone in the panel who wants to take it up, just go ahead.
Well, maybe I can start with the Industry 5.0 question. The European Commission started this Industry 5.0 like a year ago with the first like white paper, and I was reading that, and I was not sure really what the European Commission really wants to, in what direction they want to go. Well, the latest document I was reading was that Industry 4.0 is definitely a part of the, let's say, big industry, not so much of the SMEs, the small companies, but in the big industry, they're in focus of CO2 emission, the whole sustainability issue in terms of environment, but also human-centric. In Europe, we do have lots of unions, Italy, France, Germany, they are very strong, and they influenced also politics quite a bit. So what the European Commission wanted to come up with this Industry 5.0 topic was to make sure that in the future production is not just digital and resilient with supply chain and agility, and we need digital tools about that, but also need to be sustainable and human-centric. That was the idea. I don't know exactly how that should work in an economic business model sense, because we need to set, the right boundaries, the right, government influence, I would say, in order to come up with that. It needs to be connected throughout the world because CO2 emissions are all over the place and connected. So that's my view on the difference between Industry 4.0, focusing on digital aspects, and Industry 5.0, resilience, sustainability, and environmental and human-centric. At least here in Europe, I don't know if this will work out, because at the end we all want to make money. So that's my view on that.
Can I add, Geeta? So I think there is the two things that we see that will change, will advance in five. There's connectivity element, because now we have much faster connectivity options, private 5G, millimeter wave, and also we have more intelligence is going to the silicon. So 4.0 have changed from completely wired, a lot of manual processes, to become a little bit more automatic or electronic. 5.0 taking this to the next edge, which is mainly a lot of update on connectivity. A lot of the let's say 40,000 factories around the world is still using 160 different communication protocols, for example, and because they trust the wire, they trust that the cable is there. But having the millimeter wave, the 5G private network, um, having AI in the sensors and the modules more available by mass production, so at scale, will enhance that operation from both connectivity as well as throughput and yield. Now, this completely goes against, I think, what Christian just mentioned about that we don't want to forget the human there. We need the human in the factory. Let's put it on the table. It's absolutely. But I think the next generation human that's in the factory will be more educated to work on those machines and become machine operators and monitors of how the performance of the machines. So they will be the bosses of these robotics. So the robotics doesn't get smarter and attack people. So that's I think that's where the next generation factory worker will be.
Very
Just,
interesting.
just add that.
Go on,
Yeah,
you.
yeah. Industry 4.0 is a computer-aided system, and Industry 5 5.0 is an AI-aided generation, I think. So that's a difference between 4 and 5. So 4 system is a computer-aided, but 5 system is AI-aided, I think. Yeah, just believe.
So hopefully AI for the service of the people and the
Mhm.
society.
Yeah, all the AI of the internet, let's say, because when we do 4.0, we're still looking at make automation, productivity high, but we didn't associate the smart factory with a smart agriculture, with smart
Yeah.
city, with so all these things needs to be all connected. So and this requires to be thinking AI and the AI Internet of AI, let's say, and that is what we think it's going to be move forward, maybe 5.0 or even 6.0.
Yeah.
Yeah, I'd like to address the question of potential business models. I think it's very easy when we look at the arc, from Industry 4.0 to Industry 5.0, to wonder about how we continue to make money as we have all these other goals. I think if we take one step further back and put on the hat of being the people who are responsible for designing our future, for me that shifts the perspective a little bit. So I look at myself and the other panelists. We are all people with incredible backgrounds and incredible histories and have impacted a lot of things in the world. And we're part of a group of people who are responsible for designing the future that humans will live in. And if we take that responsibility, that's where I come from when I talk about the need for human-centered design in these processes from the beginning. So we're not going to have lights out factories for everything. We're going to have people working there. So for it to work, I think it's important to actually design for the people and then build out from that. And the business argument of it is actually quite straightforward. We can't completely automate. And if we don't build jobs that people are going to be willing to do, we're actually not going to succeed. given that we have to do that, why not design it so that those jobs are actually jobs that people want to do, and then the automation and the AI supports that. And I think that both gets us to something that works from a business point of view and allows us to design a future that we want to live in. Because I think it's otherwise we design something, you know, the term that I use is it's easy to design as if it's possible to automate everything, and then look at the places you can't actually automate and stick a person in there. But I think that type of design causes some of the trends that we're seeing, like incredibly high turnover and incredibly high levels of unfilled jobs in certain industries. And if that doesn't get fixed, you know, those industries will go through a transformation where the wages will go up dramatically, the amount of people willing to work will continue to shrink. So it's just a problem we need to solve at a systemic level. And if we step back and think of it as, okay, we have to have people. So now how do we design something that's sustainable with people in it? We end up with a different solution. And I don't think it needs to necessarily be incredibly expensive.
I think you brought a very, very, very important point here that you have to solve it at the systemic level. But even before we go into the systemic level, I think it needs to start from our universities. We need to train our students to think Industry 5.0. So the applications, but also applications that benefit society. So actually, we have a very interesting question on this from Ava. So she asks, how can university curriculum teach Industry 5.0 concepts to students, be it doubly or mechanical engineers, that enable them to think and incorporate sustainability concepts like the ability to upcycle, the right to repair, reducing the number of process steps in production when they enter the workforce. So teach them so that when they enter the workforce, they're already thinking along those lines. Christian, as a university professor, would you like to take that up? That will
Well,
be fine.
I can say that in mechanical engineering, the number of students are going down. Industry need the students, need master students. And what's happening is there is a war for talent, not just in industry, but also in the university itself. You know, to get the people for our project. So what I can see is there is a the students can choose, you know, where they want to go, not just in industry, but also inside the university. So what I see is there is a tremendous interest for the students to have kind of a work-life balance on the one hand. I was working crazy at McKinsey, I remember, but people today, the students are willing to work like crazy, like I did. On the one hand, on the other hand, they are extremely interested in upcycling, recycling, CO2 emission projects. We are currently doing, you know, CO2 balance projects for companies, and we figure out, you know, there's the tremendous need of knowledge how to do CO2 emission projects and then CO2 reduction projects with energy flow and so forth. And students are interested to do exactly going in that direction. So I think the curriculum is changing already. There are, you know, elective courses more and more, and students are going into that direction. And we as professors need to adapt and need to follow that. So I would say one thing is that we think about the curriculum, but the other way around is the students. If you listen to the students, they know exactly what the future will look like, because they are the future, what I said already. So it's kind of a both way, you know.
Thank you. We should probably take up another question from the audience. So Robert asks, great discussion. I'm wondering, how can industrial Internet of Things enabled by cloud services facilitate proactive management of supply chain, put centralized information, enable real-time visibility of materials from various locations? Yeah, so would you like to take that up? Supply chain management, cloud services?
Yeah, this is an interesting topic because guess where your next package gonna come from. So we see this in reality that given the challenge of logistical in the world, entire world right now, like if you want to order any part for like manufacture anything, it's like wait time and so on. There is a a real need to think outside the box, or let's be put it this way, think with the cloud, how to solve this big problem. Right now, there's systems that being put in place, and I want to stay away from advertisements, so I want to make sure I choose the right word here. There is systems that being put in place where actually will follow the crop from where it is going from the field all the way to the table, with the cold chain management of logistics and all of that stuff. The way that has to happen is really centralized on connectivity with the cloud and central system to watch everything, because that will make it easy to understand the logistical bottlenecks, as well as recalls of safety recalls, or some dangerous goods movement, for example. So if you have something in the ocean that's dangerous, you want to make sure that you have watch on it, or where it's going. There's probably piracy. There's probably some tsunami. All of this has to be monitored in a central way. And I think that new technology of a cold chain, or digital twin of logistics, going to enhance this in a commercial at scale. Right now, for example, you get like UPS, FedEx, Amazon, certain company, DHL, that actually specialize in their areas. To take this to the industry, to the general industry of everything, including agriculture, energy, you have to mimic and build over what is the model that's successful. So if you think about like warehouses, we have warehouses, for example, in Amazon, that's completely robotics. There is a human, by the way. Talking to Anthony, yes, we have a human in each warehouse, but there is a lot of robotics. If you go to the one in Riverside, for example, in California, it's a whole area of moving on robotics, which is done by our team. And take this at scale and think about the trucks and the ships and all that fleet as moving part together. And what's a good insight is monitored with the sensors. So actual sensors that actually can track them through the globe, track their temperature and shaking and all that stuff, which is available technology that has to be put together as a platform. Then that will get us to the next level of what this industry will be like.
Thank you. We have one other interesting question coming in from Catherine. Connected sensors, embedded AI, very low power edge devices. Where can they make the first big impact in Industry 5.0 from a societal perspective?
I really don't know from societal perspective. I think this question is related with Yasser just talked about the digital twin and how to deploy this unanimously, right? With ultra low power devices. Let's take a penny as a coin cell battery powered penny sensor, which has 5 modalities. And the challenge is, let's say if we put 5,000 those type of sensors in one factory, another 5,000 in a remote, like say TI pricing fab, right? Another 5,000. How many IT facility people we need to maintain these 5,000 here and 5,000? It's simple. If we pull the professional IT people into this, it's simply not sustainable or scalable. Exactly. Yeah. So the digital twin, I'm a big lover of digital twin, but I'm also struggling. Build a digital twin, how accurately it represents the physical world itself is a huge investment. So what we did is we said, okay, we want to have 0 network admin to manage this network. But to do that, I treat the sensor not just giving vibration and temperature, humidity information. I also send the network information, the SNRs, how many times it dropped connection, all these data related with network simultaneously communicate, of course, to the gateway first. We digest them and then go to cloud. But anyway, I'm able to collect all this information from the remote site. So with all the AI technology, I'm going to process and actually troubleshoot the network automatically through the data that's on the cloud side. So with today, we have 0 network admin to manage this type of network. Not saying we're not having challenge, we have tremendous amount of challenges. But bi-weekly, we receive a network status report, tell us how these sensor networks do, how well they're doing. And then we have some expert just read those reports and take action accordingly. and to expand it to the societal level. So I see that kind of hybrid. It's no longer a uniform wireless, right? Not just one type of 2.4 gig or 5 gig or millimeter wave. It's a hybrid of all these technologies seamlessly get it together. But I still think the biggest challenge sits in the reliability of the connectivity, especially for the wireless side, because of its convenience and how we put a network by itself as part of the AI and the cloud and everything. Again, that's my personal opinion for that.
Sunita, do you want to add to that?
Um, no, I don't have a specific answer to that, but I would imagine one of the big societal impact of all this, improved efficiencies and systems would be actually the reduction of greenhouse gas emissions, be it from, not necessitating, if something is remote, you actually don't have to travel that. So you can cut on the transportation and logistics. And so, my perspective, and especially kind of the background that I came from, a lot of the applications of this industry 4.0 or let's say 5.0 is a reduction in greenhouse gas emissions.
Perfect. Perfect. Anybody else wants to add to these questions and answers? Yuki?
Yeah. So low power devices and industry 5.0, not one social society in Japan. So elderly people, many elderly people live in town, and they need something help. But right now we don't have any devices for their how to say help. So maybe they have some sensors, maybe some helps give their problems, I think. So it's not for the industry 5.0, but society, I think.
Yeah, I think service robots in this case can be a big help. We have an aging population worldwide,
Yeah,
and
yeah.
I think they certainly can contribute big time to society, to the aging population, providing them with assistance, companionship. Thank you for making the point.
Mm-hmm.
It's it can be an impactful area.
Yeah.
We are almost at the close of our discussions about the questions that were posted online from our audience members. Audience members, do you have any suggestion on what the mascot is? I'm going to give the answer away. It's a cat.
I thought it's a
Is that a
Pokemon.
robotic cat? It's a
It's a
robotic cat.
robotic bipedal cat used in teaching.
It's so impact. Yeah, that robot is very cute, and everybody hugs to him.
So I'm sure we can all agree that the discussions have made us more informed and aware and inspired by the potential for Industry 5.0 to bring a positive change and impact to the world. I really want to extend my sincere thanks to our panelists for sharing their time, joining from around the world, and sharing their knowledge with all of us, and all of you in the audience for participating and exploring with us. Thank you so very much. A sustainable future would really not be possible without the participation of each and every one of us. Thank you, panelists. Thank you all.
Thank you.
Thank you.
Thank you.
Thank
Thank you.
you.
We had a great week with session on metaverse, connectivity, edge computing, and today on Industry 5.0. Today was the penultimate session. Tomorrow's session is on the future of mobility. You will be joined by a very interesting panel from academia, industry, startup, and the VC community discussing the future of mobility both on earth and in air. To continue these discussions online and to stay connected with us, please scan the QR codes and join and contribute to this engagement on digital transformation. Even after this event concludes, you can share your thoughts on LinkedIn using the tag DXWeek 2022. A big thanks again to all of our panelists and our audience members, and we hope to see you all tomorrow. Thank you.